Okay, this is AP, AB, and BC Calculus. We are doing Unit 1, Section 15, which is connecting limits at infinity and horizontal asymptotes. So let's jump right in. Some important information. If you divide a finite number by something infinitely large, you get 0. It doesn't matter how big the finite number is. If you divide an infinitely large value, if you divide by an infinitely large value, you get 0. So this is sort of like, it doesn't matter if you have 50 pizzas. If you divide it by a million people, nobody's going to get any pizza, right? Like if you have a number on the bottom in the denominator that is significantly larger than the numerator, then you end up with nothing. Well, finite numbers are always significantly smaller than infinite numbers, right? Infinitely larger numbers in the denominator would make you get a quotient of 0. So what this looks like if we want to be a little bit mathier, right, is we could say something like, let n be a finite number, right? The limit as x approaches either a plus or minus infinity of n on top of x is always going to be a 0. Because n is a finite number, it doesn't matter how big it is, it's finite, and you're dividing by an infinitely large number, that's a 0. So we're going to walk through these problems in two different ways. First way we're going to walk through them is the official way that uses this limit, right? This limit that I wrote in red, to kind of knock out a bunch of terms until you're able to simplify this into a number. The second way we're going to walk through it is sort of a logical way that plays on our understanding of what infinity does and what infinite values do, and also plays a little bit on prior knowledge from Algebra 2. Full disclosure, I default to this unless I'm required to show work on a free response. Most of the time, you're going to see these problems as multiple choice or as single point free response questions where all they want is the answer, no work. And if that's the case, and you can logically choose the right answer every time, then why wouldn't you just use the logical way that lets you skip to the end? I want to make sure you learn both ways. We're going to walk through both ways, and we're going to do that logical bit at the end after walking through the official way of doing these problems. All right, so let's go ahead and start. So when you simplify this, so if I tried to plug in infinity, I would get a bunch of infinite stuff over a bunch of infinite stuff, right? If I were to plug in, I would basically get infinity over infinity. This is one of those indeterminate forms, okay? Indeterminate forms, okay? We've seen others. We've seen 0 over 0. We've seen 0 to the 0, etc., okay? And they are never the answer, right? Ever. So they are never, ever the answer. What that means is that we're going to have to do some other math, right? So what we need to do is we need to find a way to simplify this so that we can find the answer. So when we go to simplify this, what we're going to do is we're going to take whatever the largest power in the denominator is, okay? So this is the largest x power in the denominator, okay? Doesn't matter what the largest one in the numerator is right now. We're only talking about the largest one in the denominator. And what I'm going to do is I'm going to multiply by 1 over that x. So 1 over x squared and 1 over x squared, okay? And the reason I chose x squared is it was the largest power of x in the denominator. So let's see what happens when I do that. I'm going to get that this is the limit as x approaches infinity of, so this x squared plus 3x minus 4 is being multiplied by a 1 over x squared. And in the denominator, I have a 2x squared plus 5, and it's being multiplied by a 1 over x squared, right? So that's going to look like this. Limit as x approaches infinity of x squared times 1 over x squared is just a 1. The 3x times the 1 over x squared would be a 3 over x, because one of the x's would cancel. And the negative 4 times the 1 over x squared would be a negative 4 over x squared. In my denominator, I'm going to get a 2x squared times a 1 over x squared, which is just a 2, plus a 5 over that x squared. Well, now look at what happens with these three values, this one, and this one, and this one. All of those fit that pattern that we discussed in this limit, where I have a finite number on top of an x that's approaching infinity. All three of those are going to end up being 0 when I plug in. So now when I plug in, I'm going to get 1 plus 0 minus 0 over 2 plus 0, which means my answer is a 1/2. Now again, when we get to the logic portion of this video, I'm going to show you how I can identify that in a matter of seconds, and hopefully you'll be able to as well. All right, let's go ahead and try a P1 the same way. Again, I notice if I plug in, I'm going to get a bunch of infinities on top of a bunch of infinities, which is never going to be the answer. So I look for the largest power of x in the denominator, and then I multiply both the numerator and the denominator by 1 over that power. Again, it doesn't matter if the numerator has the same power. I'm choosing the largest x power from the denominator. When I do that, I get that this is the limit as x approaches negative infinity of a negative 3, because the x cubes will cancel, plus an 8 over an x squared. In the denominator, I get a 5 plus a 3 over x plus a 4 over an x cubed. Yet again, as we saw in the last one, all of these guys are going to be zeros when I plug in because they are a finite number over something infinitely large. So I get negative 3 plus 0 over 5 plus 0 plus 0, and I get negative 3/5 as my answer. All right, moving on. Now the powers are different in the numerator and denominator. Again, I'm going to use the largest power of the denominator. I can see that if I plugged in, I would still get infinite stuff on top and infinite stuff on the bottom, right? So I'm going to multiply by 1 over x cubed on the top and 1 over x cubed on the bottom. I'm allowed to do that because that's the same as multiplying by 1, right? They're the same thing, so I'm allowed to multiply any expression by 1 if I want. On the top, I'm going to get a 5 over an x squared minus a 1 over an x cubed. On the bottom, I'm going to get a 3 plus an 8 over this x squared minus a 2 over an x cubed. Yet again, when I plug in, we're going to see that a lot of these things cancel out to 0. So I'm going to get 0 minus 0 over 3 plus 0 minus 0. I get 0 over 3, which is the number 0, right? If you have nothing and you divide it by your 3 friends, all of you get nothing, right? Okay, so here, again, largest power in the denominator. I see if I plug in, I would get something infinitely large in the top and also infinitely large in the bottom. I'm going to multiply both the top and the bottom by the 1 over x squared, right? Sorry, ignore that. All right, there we go. So I get the limit as x approaches infinity of a 3 over x squared plus a 4 over x. On the bottom, I get a 5 plus a 2 over x minus a 1 over x squared. When I plug in, I get 0 plus 0 over 5 plus 0 minus 0, which is 0 over 5 or 0. Okay, so same thing. I'm going to look for the largest power of x in the denominator, right? Not the numerator. So I'm going to multiply by a 1 over x and a 1 over x. Again, notice that if I had plugged in at the beginning, I'd get infinite stuff on top, infinite stuff on the bottom. So I'm going to get that this is the limit as x approaches infinity of a 6x plus 1 minus 3 over x over a 5 minus 4 over x, right? So if I plug in, right, if I plug in here, I'm going to get essentially a 6 times an infinity, which is huge, right? So I'm going to get a 6 times an infinity, for lack of a better way to put it, plus 1 minus 0 all over a 5 minus 0. What that means is I'm getting an infinitely large number on top divided by a 5, which is definitely infinity, right? This is going to a positive infinity because, again, you can see here that what's happening is this is a 6 times a huge number. 6 times infinity is still infinity. Adding 1 to it still makes it a positive infinity. Dividing by 5, it's still a positive infinity, so we have infinity. All right, let's do the same thing here. Again, I'm going to take the largest power in the denominator, which in this case is going to be an x squared. So I'm going to multiply by 1 over x squared. When I do that, I'm going to get that this is the limit as x approaches negative infinity of 2x plus 3 over x plus 8 over x squared over a 5 plus 1 over x squared, right? So essentially what's going to happen when I plug in is I'm going to get a 2 times this negative infinity all plus a 0 all over a 5 plus 0. This is a negative 2 times infinity all over 5. That's a negative infinity. Now, I do want to point out there is another way to do both this one and the one before. If instead of doing what I suggested and just doing the largest power of the denominator, if you just did the largest power total. So let's go back one sec. So there's another way to logic through this if you want, and it ties into 1.14. It ties into unit 14. Unit 1, section 14. If you had chosen instead to pick the largest power total, if you had chosen to take the limit as x approaches infinity of 6x squared plus x minus 3 and times by whatever the largest power in the whole thing is. And there's nothing wrong with that. It's just a slightly different way to do it, but it gets you the same end. You would have gotten that this is the limit as x approaches infinity of a 6 plus 1 over x minus a 3 over x squared, and then a 5 over x minus a 4 over x squared. If you then tried to plug in, you would have gotten 6 plus 0 minus 0 over 0 minus 0, and you got a 6 over 0, which would tell you that you had a vertical asymptote. So the answer has to be plus or minus infinity, and then you would have to do some troubleshooting to figure out which, right? So the answer the answer is plus or minus infinity, you would then have to try and use logic to figure out which. And there's nothing wrong with that, but I am going to point out that that's a little bit more difficult, right? So I shouldn't say that it's a vertical asymptote, actually. Let me rephrase that. So when you divide by 0, essentially, in a graph, it's a vertical asymptote. So what this tells you is the answer is either plus or minus infinity, but the question is which, right? So just keep in mind that then you would have to go back up and look logically, and you would say to yourself, oh, well, the numerator is going to have a whole bunch of positive infinities and a minus 3. Okay, well, that's got to come out positive. And the denominator's got an infinity and a minus 4. Well, that's got to come out positive. And so then you would have to logic your way out to figure out that it's a positive infinity. That's why I didn't recommend doing it. It's not that you couldn't. I just think it's a lot easier if you do what I suggested and just use the largest power of the denominator. Okay. Now let's do a little bit trickier one, right? So now what we're going to do is we're going to multiply, again, by this largest power in the denominator, right? So what I'm going to do is I'm going to multiply by a 1 over x and a 1 over x. But there's a problem here, okay? The problem is that I want this in the root, right? So the trick here is that for a positive infinity, right, x values that are positive, 1 over x is the same as the square root of 1 over x squared for x values that are positive, which is the situation I'm looking at because x is going to infinity. It is worth noting that in the other scenario, for x values that are less than 0, 1 over x is the same as the opposite of this. It would be a negative, right? Because if for x values that are negative, this is a negative number and the root would come out positive, right? So what I'm going to do is I'm going to take this and make this the limit as x approaches infinity. In the denominator, it's pretty straightforward. I'm going to do the 5x plus 1 times the 1 over x. But the numerator, right, is going to be this 16x squared plus 3x times the square root of 1 over x squared, because in order to distribute that in the root, it also has to be in a root. So I'm going to get that this is the limit as x approaches infinity of, in the root, a 16 plus 3 over x, and in the denominator, not in the root, a 5 plus 1 over x. Well, now when I plug in using that same rule, both this and this are going to be zeros. So when I plug in, I'm going to get root 16 plus 0 over a 5 plus 0, which gives me 4/5. And again, I'm going to show you a logical way to do this when we get to, after one more problem. We're going to do a P4, and then we'll talk about the logic. Okay, so same idea. Now, this is a little bit tricky because I've been telling you to use the largest power in the denominator. Well, the largest power in the denominator is an x squared inside a root, right? So really, right, so this is an x squared, but the trick is that what I want to do is I want to multiply by that root. So I want to multiply by essentially this root 1 over x squared, right? Now, what I want you to notice is that what I'm multiplying by here is a positive number. In order to do that on the top, I need to multiply by this negative 1 over x, right? And the reason it has to be negative is because x is a negative number. X is negative. So 1 over x would be a negative number. In order to make this a 1, right, this whole thing has to be a positive 1, right? In order to make this a positive 1, if the denominator is a positive number, which the output of an even root has to be, then the numerator also has to be that same number but positive. And the only way to make 1 over x positive with negative x's is to put a minus in front. So now, when we clean this up, I'm going to get that this is the limit as x approaches negative infinity of, this will end up being a negative 10 plus 9 over x. And on the bottom, when I distribute this, I'm going to end up in the root with a 3 plus a 2 over x minus a 1 over x squared. So when I plug in, I get negative 10 plus 0 on top of root 3 plus 0 minus 0. So I get a negative 10 over root 3. And that's my answer. If you want to rationalize, it's fine. So this is the best answer. If you really want to times by a root 3 over root 3, you could make this 10 root 3 over 3. This would be the answer in pre-calc, but in calc, the negative 10 over root 3 is fine, right? In pre-calc, you were generally required to simplify by rationalizing, but here, they're really not going to care. Okay, so those are all of the examples that we're going to do the official way that you would see in a textbook most of the time. I'm now going to walk you through what my brain does when I see one of these problems, and you can choose what you want. I would suggest that just like I'm able to do the official way if I have to, that you make sure you understand the concept, but then most of the time I think you're going to logic through this great. All right, so let's logic through this. As x gets infinitely large in either the positive or negative direction, it's really just the highest power of x that matters when we're talking about polynomials, and even things inside roots. So you can logic through the limits by simply looking at the largest terms in both the numerator and denominator to see how that fraction would behave. So we're going to walk through some with this logic. Here's what I mean by this, by the way, before I flip to the next example. Let's say that I'm looking at the limit as x approaches infinity of a 5x squared plus 3x minus 1 over a 6x squared minus 2x plus 8. My argument is that all that really matters is this. So this is what matters, right? Because with infinite values, infinity squared is so much larger than a regular infinity, is so much larger than a single 1 by itself, that this stuff doesn't. So I can't say that this whole expression is equal to 5x squared over 6x squared. That would be a lie. What I can say is that this thing behaves like 5x squared over 6x squared, which would just be a 5 over 6 for huge x values, right? For really big x values, none of this stuff matters. Now, if we were talking about x approaching the number 1, you can't do this. This is a thing that's specific with infinitely large numbers, infinitely large in either the positive or negative direction, right? So again, what we're doing is cheating and looking at some logic. So if you compare, so we're going to redo all of the examples we just did. Like this was E1, and this was E2, and this was E3, and this was E4. So you already have the answers to all of these, but now I'm going to walk through and show you how I can do it in seconds. So I look and realize that the leading coefficients, the largest values are here. I say, oh, okay, that's a 1/2, because if I looked at x squared over 2x squared, the x squareds would cancel and I would get 1/2. When I look only at the leading coefficients here, I say, oh, this behaves like a 5x over a 3x cubed, which is the same as a 5 over a 3x squared. Finite value over infinite value, this is totally going to 0. When I look only at the leading coefficients, I say, oh, this behaves like a 6x squared over a 5x, which is the same as a 6/5 times x. Since I'm going to a positive infinity, 6/5 times positive infinity would be a positive infinity. And then this is the one that usually gets people because these root ones are really hard doing it the other way. So I look only at the leading coefficients, right? So if I look at my leading coefficients, I recognize that when I take stuff out of an absolute value, it nets positive. So this top behaves like the absolute value of 4x, and the bottom behaves like a 5x, right? So essentially what's happening is, for positive values of x, right? So for positive values of x, I don't actually need the absolute value. So this behaves like a 4x over 5x, which means the answer is 5/4. If you go back and confirm, if you look at all of the answers we did in E1, E2, E3, and E4, you're going to find that those are the same 4 answers. Now, I said I could do it in a matter of seconds, and it probably seemed like it took me slightly longer than that here, but that's because I was explaining it to you. So if you get good at this and you get good at this logic, you'll be shocked by how fast you can pick the right answer. When I see a question like this on an AP for multiple choice, like if I'm a student and I see this, I am stoked because I know that I'm going to answer it in about 5 seconds, and I'm going to bank all of the other time that I would have needed for a typical problem to use in some other more difficult problem. So let's do a P5 where we do all the P problems again, and you can logic through it, okay? So again, this was actually P1, and this was P2, and this was P3, and this was P4. So if we look at logic, I look at my leading coefficients, and I say, oh, this behaves like a negative 3x cubed over a 5x cubed. Notice at no point am I saying they're equal because they're not equal. It just behaves like that. That's a negative 3/5. Okay, cool. For big values of x, that's going to a negative 3/5. The leading coefficient here is a little bit of a trap because it's out of order, but this is going to behave like a 4x over a 5x squared, which is going to be a 4 over 5x. Since x is approaching infinity, that's going to go to 0 because I have a finite number over something infinitely large. Here, the numerator power is bigger, right? So I realize that this is it's behaving like a 2x cubed over a 5x squared. which is going to be a 2/5 times an x. Well, since my x is going to a negative infinity, that's a 2/5 times a negative infinity, which would be negative infinity. And then this last one's a little bit tricky. The big reason it's tricky is because we're going to a negative x, right? So the thing I want you to recognize is that the output of an even root is positive, right? But I'm plugging a negative infinity into the top. So I'm only looking at the 10x and this square root, right? So what's going to happen is if I look at these coefficients, this is a 10 over a root 3, right? Like if I just, because what's happening is this is a 10x over a root 3 times essentially the absolute value of x. But what I want you to notice is the denominator is netting positive, and the numerator is not going to net positive because I'm plugging in a negative x, it's netting negative. So this answer is going to be a 10 over a root 3. That makes sense, but the hard part of this problem is that you have to check out that it's negative, because logically, if you look at these outputs, the numerator is going to output negative because it's a 10 times a negative infinity, but the denominator has a square root, which always outputs as positive. So what's happening is I get a negative on top of a positive, but it's a 10 over a root 3, and it comes out negative. So again, you don't have to do it the logic way. You can plug in every single time, but I will say that I'm pretty fast at these problems because of this logic, and it doesn't steer you wrong. Up to you, but just wanted to put it out there that this is a choice. So this is Unit 1, Topic 15, and have a good day.